Hello, this is Raf Alvarado and welcome to Exploratory Text Analytics. In this video we're going to very briefly look at the bag of words hypothesis. So this is one of the approaches that I described that we can take when we want to explore the statistical semantic hypothesis described by Tierney and Pentel. So here's an image taken from Dravsky and Martin's book describing the bag of words model. As you can see on the left, we have a piece of text, and it's a text in the sense that it's a series of symbols, characters, or words. The order, of course, matters, and the punctuation matters, and things like capitalization matters. And as humans, this is how we want our text so that we can read it. But to make sense of this text statistically, it's possible to do the following, which is to just simply take all the words and put them in a bag, as it were, into a data structure in which the order of the words does not matter, and in which things like capitalization and punctuation does not matter, and in which other things emerge, such as the number of times the word appears in the sentence. It's something you normally wouldn't pay attention to as a human reading a sentence. You're not typically counting words as you go, although you may sense that a word might be repeated more than once. In the bag of words model, what we're going to do is we're going to, in a way, deconstruct the message and just treat every word as an item from some inventory. Typically we'll often sort them alphabetically, or here we have them sorted in order of frequency, and then we attach a frequency value to it. And that's essentially what you do in converting a text into a bag of words. Here is a way of looking at that from the point of view of a pandas data structure with respect to the textual data that we've been working with. This is actually taken from the data that we worked on last time and that we're going to work on again this time. In item number 1, what you have is a ordered hierarchy of content objects index token table, so that the term string is, in this case, the first few words of the first sentence of Jane Austen's Persuasion. And you can see that, these are tokens in the sense that each word may appear, each term may appear more than once, and we're just simply showing them in the order of appearance, from offset 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, we can transform this into a bag of words by choosing the paragraph as the bag, and this is an important point to remember, that when we have an ordered hierarchy of contents index, we can choose any level to be our bag. We can choose the book to be the bag, we can choose the chapter, we can choose the paragraph, we can choose the sentence. Here we're going to choose the paragraph, and what we see then is an alphabetical ordering of the contents of that paragraph, and we see a numeric value associated with the frequency or the count of each term in that particular bag. So we can see that in chapter 1, paragraph 1, the word "and" appears 4 times. And finally, we can take this data structure and perform what's in pandas is called an unstacking operation. We can unstack this, and what that will do is project the last index column into a series of columns with each value in the term string column becoming a column unto itself. And here we see that we include tokens, or rather terms, that don't even appear in the first paragraph of the first chapter, and they get a 0 value. That's a vector space representation of a bag of words, and we're going to get into that in a subsequent video. But one thing to note real quick here is that you'll see there are a lot of zeros in that bottom data structure. That's what's called a sparse matrix. Every single bag is going to have a value of 0 or more for every single term in our vocabulary. And so you can imagine that this table on the bottom is really wide. It could be up to something like 40,000 features or columns, because that's kind of how many terms we have in our vocabulary, although we're going to look at ways to reduce that. So a couple of quick remarks about the bag of words hypothesis. It's based on the intuition that even though we lose word order and thus syntax and some grammatical information in languages that rely on syntax, words in a document are selected on the basis of the topic or theme of the document. This is a guilt by association principle. If words just happen to be together, even though we don't know the word order, we do have some, we are gathering some information about some common principle of selection. In other words, there's some cognitive mechanism that is choosing the words that go into a message based on what is being talked about. This mechanism tends to choose similar words given similar topics, and this is a variation of the original hypothesis regarding the signifier and the signified that we just discussed, the statistical semantic hypothesis. Looking toward the upcoming modules, this is related, this intuition that we see with the bag of words hypothesis is developed more fully with topic modeling and in a much more sophisticated way. But the bag of words representation of text that we're looking at in this module will be the foundation of other operations that we're going to perform, such as topic modeling. More generally, the hypothesis, it should be known, doesn't just apply to text. It applies to almost anything, any collection of items that are selected and grouped into what are sometimes called baskets or shopping baskets. So you may have heard of shopping basket analysis, which is a bag of items approach to looking at things. So in this view, documents are like shopping baskets, okay? And the terms that are in a document are the choices or the things that a consumer chooses, as it were, and puts into that basket. So that's why order doesn't matter. That's one way of thinking about why order doesn't matter. You're selecting elements based on some motivation. One way to think about this is that what's being captured by the bag of words hypothesis is not so much how something is being talked about, but what is being talked about. You get a sense of the topic, again, to use that term, but not much detail about the specific, things that are being said about the topic, although you can get pretty far down that path. And also tools like sentiment analysis can help you understand what is being, or how something is being said as well. So once we have things in this structure, a bag of words, we can observe some basic statistics that we can use to build derive other statistical facts. Here are just three that I'll point out that are immediately obvious. The first is you can count how many times a word appears in each bag. So we saw that already. In terms of probability, what you're looking at there is a conditional probability of the probability of a term given a document. So if I know a document, what's the probability of a word given that document is what you're basically getting, estimating when you count the words in a document. You can also flip that around and count the number of bags in which a word appears, number of documents in which a word appears. And that is the relationship, the inverse conditional relationship of what's the probability of a document given a term. And that's going to be something we can derive pretty easy from the data. And you can also determine the number of times a word appears with another word. So what's the probability of a word given another word and the documents in which those two words exist? So those are three statistics that are pretty easy to compute from a bag of words and on which we can build other statistical observations, such as the term frequency inverse document frequency formula that we're going to look at next. To conclude, I just want to share a quote that I found searching on the web for some evidence for the origin of the concept of the bag of words as it's used in text analytics. And I came across this idea. This is probably related to the point I made earlier about how it might be related to the Dadaist poet that I mentioned. Here is the American author Norman Mailer describing how movies are made, or how he imagines movies to be made. And he says something very similar to the bag of words hypothesis. In fact, he uses the expression. He says, in the novel, you start with a bag of words, and the way you put the words together has meaning. In movies, you get another kind of vocabulary. You have little bits of a film strip, each the equivalent of words, 5 words or 5,000, but the strips are put together as individual words. So this is interesting because it demonstrates a couple of things. It gives you a motivation for bag of words in the sense that you can think of bag of words as reverse engineering the process of writing. Writers, in a sense, begin with bags of words and assemble them. It doesn't. It may sound crazy, but it actually it has empirical support here. And also, we're going to see when we talk about topic modeling that Matt Jockers, who we're going to read, has a really interesting story about novel writing as pulling words out of bowls, each bowl having words associated with a particular topic. But this also shows how topic modeling, but the bag of words model relates to other kinds of media than just text and writing. Here he's talking about film, but we could talk about art that way as well, or architecture, or almost any kind of cultural product as being a bag of elements that are then assembled, selected and then assembled into structures and patterns.